Okay, so had a little technical difficulty there, got cut off. I know we were right in the middle of, I believe it's number 25. So here we are. So we identified the angle we are given, negative pi over 2, coterminal with, negative 3 pi over 2, coterminal with positive pi over 2. So I identified the location along with the point, and defined sine, cosine, and tangent, sine y, cosine x again, and then tangent y over x, 1 over 0, which is undefined because we can never divide by 0. Okay, continue with number 27. I finished this on the last video without realizing that it was no longer recording. So, trial 2. Structures are given just slightly differently. We're still given an angle on 27, and we are asked to identify all 6 of the trigonometric ratios. Same idea. We identify the location. 2 pi over 3 is here. Hopefully this is becoming a little more ingrained as we go. X and y coordinates, here and here. At this point we know y is sine, x is cosine, y over x is our tangent. Simplifying gives us negative root 3. And to find our secant, cosecant, and cotangent functions, we just use their reciprocal identities. So cosecant is the reciprocal of sine, thus sine of root 3 over 2 gives us a cosecant of 2 over root 3. Cosine of negative 1/2 gives us a reciprocal of negative 2. So on and so forth. Cosine of negative root 3 gives us a cotangent of 1 over negative root 3. Alright. Continuing. Uh, 29, very similar. 29 gives us t equals 4 pi over 3. So we're looking for all the trig functions. We need sine of 4 pi over 3, cosine of 4 pi over 3, and tangent of 4 pi over 3. Once we find them, we'll use their reciprocals. Sorry about that. We'll use our reciprocals to find their reciprocal functions. So 4 pi over 3, located here. The coordinate there is negative 1/2, negative root 3 over 2. So y is sine, x is cosine. Oops, it's a 2. Y over x, or sine over cosine, the common denominators will drop out, the negatives will drop out, so it's positive root 3. So that allows me to then just find the cotangent by having the reciprocal of root 3, which is 1 over root 3, the secant as the reciprocal of negative 1/2, which is negative 2, and the cosecant of 4 pi over 3, therefore, will be the reciprocal of the sine of 4 pi over 3, which is negative 2 over root 3, so on and so forth. So for that section, for 31 and 33 as well, we're going to follow suit, find the location on the unit circle, identify x and y, which will be your sine and your cosine, and use your reciprocal identities to complete that section. Alrighty, now, next section, 35. Please check the back of the book for the solutions to the remainder of those problems in between. 35, sine of 4 pi. So this one asks us to do something just slightly different in that this is outside of one full rotation. So we need to think about what 4 pi means. Well, an angle of 4 pi in standard position is one full rotation followed by a second full rotation, ending at the point 1, 0. So rotations beyond 360 degrees, or in this case beyond 2 pi, either way we look at a full rotation, we just think about where this terminates and use its reference angle or its corresponding angle from that point. So the sine of 4 pi we know will actually be equal to the sine of 2 pi. Very similar to the way we did negative angles, where we determine where they terminate. Here we determine a terminating location and bring it back into a term that we are familiar with. So in order to find the sine of 4 pi, we think of the sine of 2 pi. Sine is the y value there, which is 0. Similarly, 37 asks us for the cosine of 7 pi over 3. Well, the cosine of 7 pi over 3 is before we get to cosine, we need to think about where this angle 7 pi over 3 is actually located. Well, if I think of my unit circle, 2 pi is a full rotation. Well, 2 pi is 6 pi over 3, so it'll be pi over 3 beyond that. So 7 pi over 3 terminates in the same location as pi over 3. So we are looking for the cosine value at pi over 3, which we know will be the same as the cosine value at 7 pi over 3, which is the x value at that point, which is positive 1/2. So on and so forth. So going a little quicker, 39, cosine of 17 pi over 4. Alrighty, well, 1 full rotation would be 8 pi over 4. So 2 full rotations would be 16 pi over 4. So this is 2 full rotations. I'll use this graph here, followed by a pi over 4 more. So this is the same as the cosine of pi over 4. Take a moment and run through that as far as full rotations go to identify that this is in fact where the 17 pi over 4 angle terminates. And we can now think of cosine of pi over 4, which is just positive root, that's a 2, positive root 2 over 2. Final answer. Okay. Continuing. On to our next section here. Number 43. 43 tells us that we are asked to use the value of the trigonometric function to evaluate the indicated functions. Alright, so it tells us that sine of t equals positive 1/2. And it asks us to find a few things. First off is sine of negative t. Okay, well, first off, let's determine what that actually means. First off, let's assume, even though we don't know this to necessarily be the case, let's assume that t is positive, which would make negative t negative. That's opposed to thinking t is negative, in which case negative t, or negative of a negative will be a positive. Anyhow, we are looking at the sine value of some angle. So angle starts, goes in the positive direction, and it has a sine value of 1/2, which means its y value is 1/2. Well, if the angle this direction is positive, that means a similar or the same distance of rotation in the negative direction would be down here. And we can see that that is a reflection over the x-axis. Therefore, the sine of negative t would have to be the opposite of sine of positive t, which would be negative 1/2. What does b ask for? B asks for the cosecant of negative t. Well, we have already found the sine of negative t. The cosecant is the reciprocal of that. So if the sine of negative t is negative 1/2, the cosine would be the reciprocal of that, which is negative 2. We'll do one more of those. So 45. Gives us the cosine of negative t equals negative 1/5. Okay, again, we want to think of these angles. First off, a negative angle moves clockwise. Cosine is the x value. So in order for an angle to have a negative x value, it has to end up over here somewhere in the second or third quadrant. So I'm just going to draw it here just as a reference. And I know that the x value here, cosine, is negative 1/5. Okay, so we're looking at the x value at some angle that terminates on the left side of the y-axis. We're asked to find the cosine of t. Well, that means if we're thinking clockwise as our negative angle, counterclockwise would be the positive angle of the same distance, would put us somewhere here, which again is a reflection over the x-axis. Well, if we're reflecting over the x-axis, the y value is changing, but the x value is actually remaining the same. Therefore, since cosine is the x value, we have negative 1/5. It remains the same as negative t. And next thing we want is the secant of negative t. Well, secant is the reciprocal of cosine. Therefore, if cosine of negative t is negative 1/5, the secant of negative t is negative 5. Okay. 49 to 52. We're asked to find the exact values instead of what the book tells us to do, which, of course, is to punch in the calculator. These are all the values that we need to be able to pull from our unit circle without hopefully looking at it. Our goal is to become proficient to where we can evaluate these special angles or evaluate the ratios, the trig ratios of any of our special angles without needing to regurgitate the entire unit circle. So, real quick, the sine of pi over 4 is root 2 over 2. 50 asks for the tangent of pi over 3. That's sine over cosine, so we find pi over 3, put sine over cosine. The sine of pi over 3 is root 3 over 2. The cosine is 1/2, so that becomes the square root of 3. 51. Where are we at? Cotangent of pi over 4. Alright, so pi over 4? Yeah, sorry. Cotangent of pi over 4. Well, I have to think about this first as 1 over whatever the tangent of pi over 4 is. My brain does not like these reciprocal functions. I always have to find their other part, or their counterpart. So if I'm going to find a cotangent, first I need to find a tangent. Well, tangent is sine over cosine. At pi over 4, sine and cosine are both root 2 over 2. So when I put any value over itself, it gives me 1. So this is 1 over 1, which is 1. 52. The cosecant of 2 pi over 3. Well, again, I don't know that. Instead, I'm going to think of its reciprocal, so I need to know what is the sine of 2 pi over 3. Sine is the y value at 2 pi over 3, which is positive root 3 over 2. So this is 1 over root 3 over 2. Anytime I divide by a fraction, I get its reciprocal. Thus, there's the reciprocal of sine at that point, at that angle, and it is equal to the cosecant at 2 pi over 3. Okay.